Welcome to Trigonometry lecture number 2. Today we're going to remember a little bit about what you hopefully saw on YouTube, and we're going to move forward today. So I've already drawn some things up here. Recall this is the unit circle in our regular grid system. Here's the x-axis, and here's the y-axis. And we call it the unit circle because r, the radius of the circle, is 1. And this is about as round as I can draw them. So yesterday, you'll remember we were talking about degrees and radians and what's their relationship. We know that on this circle, going counterclockwise, degrees and both radians are positive. This is 0 degrees or 0 radians. As a convention, as we do this more and more, I'm not going to put the word radian by the radian measure because hopefully it will be clear in context. If I don't think it is, I will. We'll get into a pattern relatively soon. The top here, this is 90 degrees, or this is pi over 2 radians. And then once again, I'm not going to write the radians. This is 180 degrees, or this is pi radians. This is 270, and that looks like a z. I'll make that a 270 degrees. Or this is 3 pi over 2 radians. And then coming back this way, this is 360 degrees, or 2 pi radians. And similarly, if we go around again, we're going to end up adding all these things up again, and here will be 720 degrees, or 4 pi radians. And we can keep going and going and going. Basically, once around the circle, we're adding 360 degrees or 2 pi radians. Why are we doing this with radians? You think there's enough that we're asking you to try and understand. Why did we need to introduce radian measure? And that's an excellent question. And the reason is because it's unitless. And what that means is that it's a scalar. It's just a number. And this is important when you're doing physics and computations. Remember that theta, which is the Greek letter theta, this is defined, and I'll put this like this, theta is defined as the arc length, or this length, divided by the radius. Both of these are going to be in some kind of units of length. When you have unit of length divided by unit of length, they cancel out and you just have a scalar number. So this is S divided by R. And this has a lot of great conveniences that the degree measure doesn't have. However, it is very common to still use degrees when we talk about things because some things are just so obvious. I don't know if this is exactly right, but so if here's the crosshairs on this. Let me find, I guess I'll put green. So these diagonals here are also very commonly used. This is 45 degrees or pi over 4 radians. We already have this one. This is, so what do we do? 45 plus 45 is 90. 90 plus 45 is 135 degrees. How many radians is this? Well, every 45 degrees is pi over 4, so this is pi over 4 plus pi over 4, which is pi over 2, or plus pi over 4, so this is going to be pi over 2 plus pi over 4. This is the same as 3 pi fourths radians. Similar, this is pi radians. If we're adding 1/4 pi, another 45 degrees this way, and incidentally, so maybe I should fill this in. This is 45 degrees past 100, so this is going to be 225 degrees. Pi plus 1/4 pi, this is 5 pi over 4, or 1 1/4 radians. This is 6/4 pi, but we write this as 3 over 2 radians. It's kind of bad form to leave a fraction this simple unreduced. This is just 3 over 2. And I'll be mean to you if you don't. Not really, but somebody will be. So try to keep it in mind. What is this? Well, this is 270 plus 45 degrees. This is 315 degrees at this diagonal. And if this was 6/4 pi, which we wrote as 3 over 2, now this will be 7/4 pi. And there's a reason why I'm pestering you with these again. It's very good to know these by heart in whether it's in radian measure or whether it's in degree measure. I had a very good question today. Somebody said, when I'm doing these calculations in my calculator, should the button be on degrees or radians? And this is a great question, but until we get to the trigonometric functions, it doesn't really matter. And the reason is that everything we're doing, like suppose yesterday I said we were going to figure out how much 1 radian was, and then I forgot to do it. What is 1 radian? And remember our conversions. If we're converting, we know that there are 360 degrees for every 2 pi. A circle going around the circle in radians is 2 pi. That's contingent with 360 degrees. Notice I'm not writing the word radians there. I'm just kind of expecting that it's understood. A 2 will come out of this. So there are 180 degrees for every pi radians, which also means, so this is like one thing. This is like 1 foot divided by 12 inches. This gives you a way to convert inches into feet. This gives you a way to convert radians into degrees. Similarly, if this is upside down, pi radians over 180 degrees, this gives you a way to equate degrees to radians. And once again, let me go back to this question. Do we need to have a calculator in degrees or radians? Right now, it doesn't matter. For this kind of work, what we're doing, as I said before, what is 1 radian? I don't think I did this yesterday. So I'll write this 1 radian. What does this equal in degrees? Well, so we're starting with radians measure. We want degrees. So what we want to do is we want to cancel the radians from top and bottom. Radians on top, we have radian on the bottom. We're going to do this. So 1 radian, and I guess I will write in the radians to show them canceling. I hope I'm not driving you guys crazy. If I am, complain. So I want this to be in degrees, so I'm going to use the translation with degrees on top because that will survive. It's 180 degrees over pi radians. And as I said, I wrote the radians in here because I want to show you these measures cancel. So this is 180 degrees over pi, which is now just a number. And how many degrees is that? Well, so my calculator is on radians right now, and it doesn't matter, and I'm going to show you, and I know you can't see that it's on radians. 180 degrees, I don't have to hit degrees, it's just a number. 180 divided by pi is, this says it's 57.2957791 degrees. Remember, pi is like 3.14. It's 180 divided by 3 and some change. If I have this set on degrees, which I will now do, so now I've set it on degrees, I do the same computation, 180 divided by pi. It comes out to be the same thing. The difference between radian and degrees will really come into play when we're figuring out the sine of 45 degrees is definitely not the sine of 45 radians. But you guys don't need to know this yet, so that's no big deal. So we're back here, and we are back doing some conversions. Hopefully these conversions aren't too hard to think about. Remember, radians are the arc length of a circle divided by the radius of this. And now I'm going to clean the board, and so why don't you take a quick break.